When I was teaching, I would have my students write toy operating systems or toy compilers. And my students knew that they would never be using this in real life. On the other hand, today, what I would do is I would say to them, take a portion of the Linux kernel and try and improve it. Try and make it better. Extend it in some way. Write a device driver. And now they would be getting experience in something that's used by millions of people all the time. That's the difference. Now, I've been talking about what it means to use free software in computer science. And I'd like to go over a little bit about the types of things you could be teaching if you're teaching computer science with free software. First of all, if you're teaching a course in operating systems design, it's not only the Linux kernel that you can show people, but you can show them a wide range of different kernels. OpenBSD, FreeBSD, NetBSD. One called FreeDOS, which is a simple DOS-based kernel. You can see how that works. It's much simpler, much easier to get your whole head around FreeDOS than it is, say, a Linux kernel. TinyOS is a tiny little operating system used for places that you have even less memory or less resources than you would have for a Linux embedded system. CMU Mach, a microkernel version, and based off of that is the Herd, which is a kernel that's being done by the Free Software Foundation. Yeah. These are all different kernels that people can look at, all open source, but they can see the different techniques that people use to do this thing that schedules memory, schedules the processes, and things like that. These are not toy operating systems. There was another operating system called Minix, done by a person named Andy Tannenbaum. The problem with Minix, and particularly back in the days that the Linux kernel was started, was that it was built to demonstrate an educational system. It was not built to actually do real work. And consequently, there were trade-offs that Mr. Tannenbaum made in that system. And when Linus started the Linux kernel, he recognized those, and that's why he didn't base it, plus the licensing of Minix at the time kept it from being generally useful. Now, Linux is a multi-user operating system. Why is this important? Unlike DOS, a multi-user operating system has to have built into it a certain amount of stability and security that keeps the users separate from each other. Multitasking, why is that important? You want to be able to have tens of thousands of processes operating at the same time. If the operating system was fragile, there's no way you could keep all of those going enough. It's multi-threaded, so you can have multiple CPUs going through the kernel at the same time. It's multitasking, it's multi-architecture. Why is that important? Because if you build an operating system for only one architecture, a lot of times the people that build the operating system take shortcuts. They take advantage of things in the computer architecture. By making it architecture neutral, you tend to make a more stable system that changes better over time. It's 32-bit and 64-bit compliant. Why is that important? 32 bits, you can access either 3 or 4 gigabytes of data at one time. With 64 bits, you can access 4 billion times 4 billion bytes of data at once. That's enough to have the entire movie into memory at one time. It's enough to have 128 bytes of data for every square millimeter on the surface of the Earth, including all of the oceans. It's enough to fill up a 1 gigabyte disk every second of the day, every day of the year for the next 5,386 years, and still not run out of address space. So this means you can actually write an application without having to worry about artificial boundaries created by running out of address space. Now, Linux was made to be 64-bit in 1995. There's a certain commercial proprietary software generated in Redmond, Washington, that didn't become truly 64-bit until a couple of years ago with Vista. So Linux was fully 64-bit 12 years before a certain proprietary operating system was. If you're interested in file system design, there's a whole plethora of different file systems which are available to you. You can see how the file systems work. You can see how a journaled file system works, how a log-based file system works. There's network file systems you can look at. Every type of networking under the sun is available with free and open source. You can see that the stacks are working. I've only got 5 minutes yet. I don't know how I can do that. If you're interested in security, you can see projects like Kerberos for distributed security or SE Linux. Different graphics systems are available to you. Clustering is available. But it's not just the operating system. If you're interested in compiler design, you can see compilers for almost every language that we've ever done. The only full implementation of Ada still in existence is a free and open source project. It's also about telephony. You can see voice over IP. You can learn about Asterisk, a free and open source PBX system. Android is an operating system for telephones. You can take a look at that, see how it's made. It's not just about software. If you're interested in hardware, electrical engineering, there are tools, the free and open source tools for being able to design the hardware, create the printed circuit board, do the simulation, and actually be able to create the hardware itself. I was at a thing called Campus Party. I saw a person actually designing a system, washing off the printed circuit board in the men's room after they had created it at Campus Party. There's a thing called Arduino. It's a tiny little computer system which is an open hardware design, and you can get open software to teach students how to program the hardware, actually how to build it. Very, very exciting. You can excite the students with free and open source software. As you know, most students hate math, but they love music. I got good news and bad news. The good news is that you can combine math and music to create even better music. The bad news is you have to learn the math. But FOSS is not just about computer science. It's also about social studies, because you can utilize some of the free and open source software to do statistical packages and look at geographical information. There's very, very expensive software from companies to do geographical information studies. But now you can get this software in a free and open source at no cost to you. It's not just about this. You can also use free and open source to talk about English, for example. If you're teaching English as a second language, there's things like Project Gutenberg, where there's over 100,000 out-of-copyright texts available over the internet so that people who are learning English, either English or English history or English literature or English as a second language, they can pull them down, they can search them at no cost to them other than access to the internet. You can use free software to talk about patent reform or about things like Creative Commons licensing and what is the advantage and disadvantage of that. You can teach use of business practices. Free and open source software does not treat software as a product. It treats software as a service. Now, a lot of us don't like the concept of service because we think of service jobs of things like flipping hamburgers and things like that or waiting tables. I prefer to think of free software as a service job like brain surgery. You do not end up with a second brain when a surgery gets finished. They repair the brain you have. It's a very expensive service because you trust the brain surgeon a lot. You're not paying them for the 40 hours or for the 40 minutes they spend in the operating room. You're paying them for the 28 years it took them to learn where to make that cut. And you don't go out into the newspaper looking for brain surgery cheap. You know, hey, use my brain surgery. I do it cheap. I don't wash my hands in between surgeons. You don't do that. You look for the best brain surgeon you can. Certainly, lawyers don't create any products, but you pay a lot for their services. So, FOSS is actually also about the arts and Creative Commons. And if you go out to SourceForge, out on the net, you find out that there's over 230,000 different projects you can have that are contributed by 2.3 million different developers. And this is without the rest of the world actually embracing it. So what we're doing here is we're creating a new model of developing software. It's actually an old model. The concept of creating software as a product happened between the ages of 1977 and 1990. And that's when it started to fall apart. Tomorrow, I'll give a talk on the hidden costs of proprietary software. You'll see why the proprietary soft model is falling apart. Unfortunately, I don't have enough time to do that here. So these are the new things we have to teach about this new model. We have to teach about distributed development. You may not ever meet the person you're working with. We have to talk about how to license the software so you can still make a business while you're making the software. We have to work better at developing formal standards so that you can improve in, above, and below that standard level. We have to show people how to be able to write the code to those standards and how to motivate people to work with us. These are things that are different than a lot of the things we've been teaching to students in the software industry. Things not to teach. Do not teach Microsoft Office. If you're going to teach something, teach comparative office system design. Show people OpenOffice, K-Office, show them Microsoft Office, but then allow the students to pick the best tool for the job. People say, I teach Microsoft Office because that's what everybody in the world is using. I have a problem with this. You're telling me that your students are smart enough to build bridges, to drive the world of tomorrow, to be able to do brain surgery, but they're too stupid to pick up a book on how to use Microsoft Office and learn it in a day. If that's what you're telling me, I have a problem with it. We need to be able to teach students the fundamentals, how the computer actually works. It is not enough to just teach them Java. Because if they don't know how the computer really works, then they're going to make wrong programming decisions. I don't think that any student should be programming in assembly language or machine language today. However, if you don't know what the compiler is generating or how the operating system works, your programs are going to run very slowly. And don't teach specific products like Nortel. I think that's probably the end of my time, and I don't want to take it away from the rest of the people. But there's lots of different things in free software which you can teach students, you can get them interested in, and you should be looking at using it. Thank you very much. We have time for a couple questions. If you ask me the question, I'll say it for the camera, and we'll try and make them quick. Any questions? Yes, sir.
Well, what you're describing, teaching the general ideas and concepts sounds good, and I'm familiar with it. But what I'm seeing more and more and reading more and more is that employers these days, it's like just-in-time manufacturing. They're trying to do just-in-time or just-in whatever.